thinking of one dimension. We know only this, but we don't know what is collision, what is inelastic collision. First, let me explain the terms and then go to the actual experiment. First, let us talk about the collision. What is collision? Anyone? Anyone can explain collision? Shabab?
I have no idea.
Okay.
I think I know, Doctor.
Yes, please.
Collision is the, for example, two cars bomb.
Yes. Collide with each other. That is meeting physical
Crash?
contact. Making
Okay.
physical contact called as a collision. There are different type of collisions out there. And you gave one example, the collision between two cars. Can you give some other example for collision?
Collisions
Other example for
between
collision.
two
the
balls,
ground.
Doctor.
Two ball. Yes, you're right. Yes, any other?
Ball hitting the ground.
Yes. No, hitting the ground. Okay, I can take it. Yes, another. Another example.
Crash two cars.
Yeah, with this, one student told me this. Told this already. Any other example, please?
Maybe
Okay.
kicking the ball.
Same. Hitting the ball, hitting the ground, kicking the ball is almost the same. Same category. Yes. I think you are familiarized with the billiards. The game billiards. Do you have any idea about that? Billiards or carom board? Carom.
Yeah, I know
Yes,
it. I know it.
Yes. Yes. Now you realize what is collision. You are hitting a coin to move another coin. The coin first to move with some speed and hit the other coin, make the other coin to move. This is a very simple example for collision. And in the carom, you are hitting the striker only. The striker goes and hit another coin, make it to travel some more distance. These are the basic examples for collision. Is it clear? Now, there are to understand the collision, we should understand one more physical quantity called the momentum. You should understand momentum in order to understand the collision perfectly. What is momentum? Momentum is a physical quantity. It is a physical quantity. It can be represented by the letter P. The letter P is a represent symbol to represent the linear momentum. Okay. How to calculate? How can I calculate the momentum of an object? The momentum can be calculated by using this formula, m into v. M is the mass of the object and v is the velocity of the object. Only moving objects have this property called the momentum. The momentum is a vector quantity. How it is vector? The momentum can be calculated by multiplying the mass with the velocity. The mass of your body is a scalar quantity. The velocity is a vector quantity. The velocity is a vector. If you multiply a scalar with a vector, the resultant will be a vector quantity. Okay. The direction of momentum, linear momentum, direction of velocity will be the same. Now you understand how to calculate the momentum. What is the meaning of the momentum? What do you understand from the momentum? The momentum is the ability of the object to transfer its motion to the other object when coming with the physical contact with each other. The momentum is the ability of the object to transfer its motion to the other object. For example, you have a object here. The object is at rest. It's not moving. We have one more object of mass m is traveling with the velocity v. It is traveling slowly, right? The coin, the carom board coin, if you take a coin, Sorry, carom board. This is the packet. The coin is very close to this. Now you want to make this coin to travel slowly, right? Slowly. Then what you will do? You take a striker, you apply a small force. Am I right? You apply a small force, the
Yeah.
striker will move with a low velocity, less velocity. When it hit this coin, it make the coin to travel slow. Now the ability, it is transferring its motion to a lesser level. And the momentum is less because mass is the fixed, v is the small. When v is small, the momentum is small. Suppose the coin is here. You want to packet this coin in this. It has to travel a long distance. Now, how will you hit? You will hit the striker with a slow force or larger force? Small force or larger force?
A larger
Right?
force.
Larger force. Why? You want to make the object to travel a long distance. You travel a long distance, therefore you have to apply a larger force. When you apply the larger force, now the striker is moving with a larger velocity. Now, when the velocity is larger, what about the momentum? The mass is not changing. For this case and this case, the mass is not changing, but only velocity is changing. When the velocity is higher, what about the product momentum? Is larger. Now, it efficiently transfers its motion to the other object. After transferring, the coin travel a long distance. Now you understand what is momentum? The momentum is the ability of transferring its motion to the other object. It's called as momentum. Let me come to the classification of the collision. There are two types of major type of collisions. The one is elastic collision. One is elastic collision, and second one is inelastic. Right? Elastic collision and inelastic collision. What is elastic collision? Now let us take the example of the billiards, right? The billiards, elastic collision. What is this? Elastic collision. Now in the elastic collision, the example is the billiards ball. The example is billiards. And after collision, you are hitting the striker with the coin ball. After collision, just imagine the two objects moving with the same speed or different speed. So different velocity or same velocity?
A different
What?
velocity.
Different velocity. Moves separately. Moves with different velocity. Move separately, right? The two objects after collisions move separately. This is a perfect elastic collision. Number two, after collision, do you find the change in the shape of the object? The shape of
No,
the
there is
ball
not.
changes or not changes?
No, not changing.
Not changes. No changes in shape. Number three, there is no loss of energy. There is no loss of energy. How can you understand this? If you play the billiards for 1 hour, at the end of the 1 hour, at the end of the play, can you hold the ball in your hand? Is the ball hot or no? After
No, it's
playing
not.
1 hour,
It's not
it is
hot.
not hot. It is not hot. That means even if you play continuously for an hour, the ball is not heated up because there is no loss of kinetic energy. No loss of kinetic energy. No loss of kinetic energy. These are the important properties of elastic collision. After collision, the two objects move separately with a different velocity. There is no shape. There is no change in the shape. there is no loss of kinetic energy. And in an elastic collision, the momentum is conserved. Pi is equal to Pf. Initial momentum is equal to total momentum. And kinetic energy is also conserved. Kinetic energy initial is equal to kinetic energy final. These are the properties of elastic collision. We are going to do the elastic collision experiment later. Now, we are doing inelastic collision.
Doctor, here,
Inelastic.
Pi equals to Pf or P total?
Pi is equal to Pf.
Okay.
In inelastic collision, what is the example for inelastic collision? Let us say a small car is on the road, it's not moving. A big truck, very big truck, is coming with a larger speed. When it hits with the car at small car at rest, what happens? After collision, these two objects move together or move separately. Just imagine.
Together.
Move together.
Together.
Together, yes.
Yes, this is the big object, the small objects move with the same velocity. And this type of collision is called as inelastic collision. Move together. After collision, they move together. And due to this type of inelastic collision, do you find the change in the shape of the object? After collision, shape of the car, shape of the truck, will it be the same or changes?
No, change.
Change. It's a change in the shape. Change in shape of the object. Number 3. And during this type of head-on collisions, sometimes the vehicle catches fire. Why? And if you touch the body of the car or after accident, you will feel hot. Why this became hot? Because a part of kinetic energy is lost during the collision. You know, the conservation of energy states, energy neither created nor destroyed. You can convert one form into other form. Your kinetic energy disappear, lost. But that lost energy reappear as thermal energy. Now some amount of heat is generated on the body. And when there is a spill of gas, and due to this heat, and that vehicle catches fire. Now here, the kinetic energy is lost. The kinetic energy is lost in elastic collision. Now you understand elastic inelastic collision. And this experiment we are going to do only inelastic collision. Both the collision, the momentum is conserved. Momentum is conserved in elastic collision and inelastic collision. What is the difference? The kinetic energy initial, kinetic energy final, they are not equal. But here equal, elastic equal, inelastic it is not equal. Why? There is a loss in the kinetic energy in the case of inelastic collision. Clear? Now you understand what is inelastic collision, right? And let us come to the objective. To verify the principle of conservation of momentum for inelastic collision in one dimension.
Doctor, I have
We are going to
please.
verify the conservation of momentum. Yes, Shiva?
Can you please go back to the whiteboard?
Why?
I want to take a picture for it, if you want, Doctor. Oh.
Done?
Mm-hmm.
Okay.
Yes, done.
Okay. And now let us come to this. We are going to verify the conservation of principle of momentum. That means initial momentum should be equal to final momentum. To verify the conservation of principle of momentum, we need to maintain one condition. Let me ask you one question. Before starting the play with the carom board, you are applying the powder on the board, What surface? Why? Anyone?
To make
At the beginning of
to make it move faster.
move faster. You can hit fast, then it will move fast. If you apply more force without applying, so you can make the coin to move faster.
Move
There is another choice.
smoothly, doctor.
Yes,
Like
smoothly. And that is important point. And you want to reduce the friction between the two surfaces, the coin and the board. This is the main objective of adding the powder on the carom board. Why it won't be smooth? You want to reduce the friction because the principle of the momentum is conserved. The conservation of momentum you can apply only for isolated object. Not only conservation of momentum, any conservation principle is applicable only to the isolated system. What is isolated system? The system should not have any contact with the surrounding, right? The coin. Now you are going to talk about the collision between the coin. The coin is moving over the floor, the surface of the board. I want to isolate the coin from the board. What is the contact between the coin and the board? It is the frictional force. By applying the powder on the surface of the board, I can minimize. The friction cannot be equal to zero. I can minimize the friction. Now the coin seems to be isolated from the surface. Now this is the reason for applying the powder. Now we are going to check the conservation of momentum. Here also I want to isolate the object. What are the two objects here? Like coin, the glider 1 of mass m1, the glider 2 of mass m2. Both the glider are traveling through a platform, right? Air track. Now, in the normal case, there will be a friction between the glider and the air track. I want to reduce the friction. How can I reduce? By blowing the air. Blowing air on the small hole provided on the air track, I can neglect the friction. I can minimize, not neglect, I can minimize the friction. Now, if the body is isolated, I can apply the conservation of momentum to the isolated body only. Okay. Now come to this. Now the body became isolated. I can apply the conservation principle. Now take this object. The glider mass m1 is traveling with the velocity u. In this book, they are using letter u to represent the initial velocity, v to represent the final velocity. U means initial velocity of glider 1, glider mass m1. And the glider m2 with mass m2 is not moving. Now what is the initial momentum? The initial momentum pi is equal to m1u. Is it right? m1u plus 0. Why 0? Because the velocity, the u2 equal to 0. The velocity of second glider equal to 0. Therefore, that momentum equal to 0. Now, you are pushing this glider m1 with some force. It travel with the velocity u and go and hit the another object, the m2, glider m. After hitting, now see this, the two glider attached together move with the same velocity. And this kind of collision is a very good example for inelastic collision. Inelastic collision, the two objects move together with the same speed. Now m1, m2 attached together and traveling with the speed v, right? And the u and the v can be measured by using gauge.
Doctor, what's the gate here?
I will show you. The gate means, the photo gate means it is the device used to measure the velocity. It is measured velocity. Using the photo gate 1, I can measure u, and using the photo gate 2, I can measure v. Clear? Now, what is the final momentum? Pf. Pf is equal to what is the total mass? m1 plus m2. What is the final speed? V. Now, this is the final momentum, this is the initial momentum. According to the conservation of momentum, initial momentum should be equal to final momentum. See this? And if these two are equal, we can say the momentum is conserved. If you find the difference between these two momentum, initial momentum and final momentum, the theoretical value of difference should be equal to 0. Am I right? Shabab, what is delta P? Delta P is equal to Pi minus Pf. Do you understand, Shabab?
Yes.
Pi minus Pf. The difference should be equal to 0, theoretically. If this
Doctor,
difference between the
not
Shabab,
PF minus PI, the
anything,
final.
anything you can take. See, Pi is equal to Pf, right? If I bring this to one side, Pi minus Pf is equal to 0. Or if you take this to other side,
Doesn't
Pf
matter.
minus Pi equal to, that doesn't matter. Doesn't matter.
Yes.
You can transfer one quantity, other quantity, both give the same meaning. Is it clear? My
Yes,
aim is to find the difference between these two. The difference between these two should be close to 0. If one difference is positive, other will be negative. But the magnitude will be the same. Is it clear?
Clear.
Okay. Now,
yes,
this
yes.
we are going to do, calculate the initial momentum, final momentum, find the difference between these two momentums. If the difference is very, very small, and then we can say the momentum is conserved. The first one, we are going to measure the mass M1, the mass of the glider 1, we are going to measure by using a triple balance. The mass of the glider 2, we are going to measure by using the balance 2, sorry, the balance, triple beam balance. M1, M2 measured, expressed in terms of gram. Now come to the new term. What is delta? Delta is the extra load, extra mass. The delta is the extra load or extra mass. We are going to add extra mass only to the glider 2. How much extra mass we are doing here? We are adding here 10 gram. 10 gram, you are adding 5 gram one side, the 5 gram other side, equal loading, right? You add for 10 gram. What is the new mass of the glider M2? Is actual mass. You can add this with this. The U is the initial velocity of glider 1. You can measure U by using the timer. I will show you how to measure this. And V is the speed of the glider, the combined glider M1 and M2. The final speed of the glider M1 and M2. The Pi is the initial momentum. You can calculate by using this formula. P of the final momentum you can calculate by using this formula. The error percentage you can estimate following this formula. So repeating this experiment for different extra load from 10 to 100 gram. Now I will share you the video of the experiment. What is that? The video, I did not take it. Subject. Semester 403. No, not here. Yes. Body is a video in elastic collision. Inelastic collision in one dimension. The objective of this experiment is to verify the principle of conservation of momentum for inelastic collision in one dimension. In inelastic collision, the two objects, after colliding, combine together to move with a common velocity. And this is the ideal inelastic collision. In inelastic collision, the momentum is conserved. Initial momentum is equal to final momentum. But the kinetic energy is not conserved in the inelastic collision. Both elastic and inelastic collision, the momentum is conserved. We are going to verify conservation of momentum in inelastic collision. Let me introduce the equipments we are going to use in this experiment. And this is the air track. We air track in order to remove or neglect, eliminate the friction between the two surfaces. And this air track is connected to the compressor. The air compressor compresses the air and send it to the air track, and the air is blown through a small hole the nozzle is provided, and thereby it reduces the friction. The friction is nullified. Now, any conservation loss is valid only for isolated objects. The conservation principle is to apply the isolated object. This is air track, and we have the two objects. The object one. Shraf, you're talking about the gate one. This is the gate one. Yes, this is connected to timer one, and when the glider crosses this region, this will inform the timer to make the measurement. Right? This is the glider 2. This is connected to another timer. By using the glider 1, we are measuring initial speed of glider 1. And this is the timer 2. This will measure the final speed of glider, both the combined glider, M1 and M2. Object 2. The mass of this object is M1. Mass of this object is M2. And we have two gates. This is gate number 1, the gate number 2. We are going to measure the speed of the objects by using the timer. The timer we are going to use in your speed mode. We are going to measure the speed. We can select the speed by using the select button. Speed. Then we are going to use one gate, and using the select mode button, you can select one gate, and this instrument is ready. When it is perfectly ready, you can press the start button and you can make the measurement. And similar setting we are going to make in the other gate also. To begin with, we have to measure the mass of the glider 1 and glider. This is called as triple beam balance. First, you have to prepare the triple beam balance and put all the masses this left side and arrange this mark should be touching 0 mark. Then place the mass to be measured on this pan and adjust this one and bring the mark close to 0. Then you can measure the mass of the object by using the triple beam balance. And you can keep it here and measure the mass. This is the glider with the needle is taken as M1. The glider without needle is taken as M2. We're going to measure the mass. Then we have to measure the mass 200 plus 0 plus 4.7. You have to record the mass M1 in the place given. 204.7. 204.7.
Excuse me, doctor.
Yes.
This point, I don't understand it. How you get the... What are
you are adjusting this until you get 0, right? Sorry, touching 0. Until touching 0, you are moving left or right, this masses, you will get 0 position. Now, the position becomes touching 0, now you are measuring the masses. There are 3 beams. That's why we are calling it the triple beam balance. This is hundreds how much is 200 plus this beam. This beam shows 0 gram. 200 plus 0. This beam 3, it is 1, 2, 3, 4, 4.7. 200 plus 0 plus 4.7, 204.7. Clear?
But the last, doctor, you changed it by yourself, doctor.
What is you checked by yourself?
This 4.7.
Yes, see the key here. This is for 4.5, 6, 7. This point is showing 7. There is a mark, right? At the center.
I think, Doctor, he asked why did you change it? We changed it to get 0 on the right side, right?
Yeah.
That's, I think, what he's asking.
Changing to get 0. See here.
Okay. Now
we are changing this position to make this point and 0 are equal.
Yeah.
Coming in the same line. Clear. Before that, it was not 0, right? Where is that? See. Now it is more than that. Yeah, now it is less, right? It is different. Adjust the mass so that it is touching 0. Clear?
That's clear. Thank you.
Okay. This done. Take out this and measure the mass of the glider 2. The glider 2 is without the needle. Now, sometimes both the mass may be the same, sometimes it is different. Now, there is a slight difference. I think same now. Same. Then you can write 204.7 gram. Now, this part is finished. The next, we are going to load the glider 2 with the extra mass. These are the extra masses. We are going to load as per the information given here. Delta extra load. First, we are going to load 20 grams. And both sides, you are going to load equally. 10 grams. Only M2, you are going to load extra masses. 10 gram this side, 10 gram other side. 6. Then, now you are going to perform the experiment. And you can keep the distance between the two gates approximately. Keep it here like this. Keep the distance approximately between this. Now the instrument is ready. And keep the speed 1 gate mode. Press the black button. This is it. And similarly, the speed 1 gate mode. Press the button. M2 should be between these two. And M1 should be at the left side. Now you have to push gently the M1. You are giving the slight force to this. Now this is moving. The V1 can be measured by using the gate number 1. Now this will go and hit it, and after collision, both objects move together. Now let me apply this. Now after collision, both objects are moving together. Now this is U, 14.0. U is 14.0. And this is V. V is 5. Now we continue this, repeat this experiment for different values of delta. Next delta is 40.
Doctor,
40.
the distance between the two gates, does
Yes.
it matter?
Yes?
The distance between the two
The
gates.
distance between the gate, I told you how to fix it. See this. You are keeping this. One should be this end, other should be the other end. We are not fixing any length. We are fixing approximately. Both should be either side of the arrangement. Approximately between this. Push gently. And after U.
Doctor,
Yes.
in this calculate, All of it is speed and 1 gate, right? All of it.
Yes.
1 and 2.
Speed 1 gate.
Okay.
Repeat this experiment for different values of delta. Next delta is 40, 20 other side. We are going to load 20 more grams. 20 one side and 20 more grams other side. Now the total load, extra load is 40 grams. Again, you are going to repeat this. Before starting, and press these two buttons. Ready? And keep it here and push gently. Now this is some speed, and this is U, and this one is V. You have to note down here. 9.2 is U, 4.2 is this. And you repeat the experiment continuously until the last load. The extra load is 90, 45 one side, 45 the other side. You are going to complete
Doctor.
this.
Yes. Doctor.
Yes.
Why the initial speed is changing?
You are pushing, Shabab. You are pushing. If you push fast, then
Why
speed will be
the
fast.
initial speed is changing?
That's what I'm telling. You are pushing by your hand. That is not going to affect your result, because we don't have the instrument to push the equipment. You are pushing. Sometimes you push faster, sometimes you push slower. If you push fast, the speed is larger. If you push slow, the speed is smaller. This is not going to affect your final result. The M2 plus delta. This is M2, this is delta. At 204.7 plus 20. And this is 224.7. And already we noted down U and V. Then first we are going to calculate the P1, PI, the initial momentum. The initial momentum is equal to M1 into U. M1 is 204.7. U into 14 is equal to 2865.8. Pf, that is the final momentum. This final momentum is equal to M1 plus M2 plus delta into V. This is M1 204.7, M2 204.7 plus 20 into V. V is 6.4. If you multiply this, you are getting 2748.16. This is PI, this is PF. And your error is PI minus PF. This minus this divided by this plus this. Into 100. You get 2.09%. 2.09% error between the initial momentum and final momentum. Theoretically speaking, the percentage of error should be very close to zero. Experimentally we got, but experimentally the error cannot be. Most of the time will not be equal to zero. Here we got the error 2.09%. Inelastic collision in one dimension. Objective of this experiment. Yes. Is it clear to you, Shabab?
Can we see download the video? If I want to check
The
something.
video size is very big, Shabab. I cannot upload on the blackboard.
I
The
understand.
video size is
If
GB.
you can, Doctor, repeat the last part.
The video size is very big. I cannot be able to upload on the blackboard.
Doctor, can you please show me how you calculate the distance between the gates again?
In order to remove or neglect the slight difference. Now this part is to load. You are going to distance. See that? Keep it here. See how I'm fixing the distance between two gates. Keep the distance approximately between this. Is it clear? Now the instrument is ready.
Approximately, Doctor. Not.
Yes, approximately. One is the left side, another the right side. The gap should be filled by the two gates, the two gliders.
Fill the two gliders.
Yes.
Okay.
Between the gate, the two gliders should be placed.
It should
Perfect.
be fit. Mhm.
Yes. No need to measure the distance between these two gates. It's clear?
And can you repeat
Yes, yes,
the
clear.
last 2 minutes maybe?
Yes?
And can you repeat the last 2 minutes in the video? Because there is some issues on my internet
Yes.
and the video is lagging.
M2 4.7 plus 20 into V is 6.4. If you multiply this, you are getting 2748.16. This is PI, this is PE. And your error is PI minus PL. This minus this divided by this plus into 100. You get 2.09%. 2.09% error between the initial momentum and final momentum. Theoretically speaking, the percentage of error should be very close to zero. Experimentally we got, but experimentally the error cannot be, most of the time will not be equal to zero. Here we got the error 2.09%. Inelastic collision. Yes, clear?
Yeah, clear, doctor. But one question, and if I want to take the mass, there is three things. The first one I put it in zero, right? And the another
Yes,
thing.
yes.
Okay. Now it's clear. Okay, thank you, doctor.
Okay. Now I'm going to share you
Doctor,
the data. Yes.
doctor, excuse me. I have a question.
Huh?
Can you back? Excuse me.
What is your question?
No. Now I can see it.
What is your question? You tell me.
My question is mass of glider and antly mass of glider
Pardon? Mass of the glider and
and until mass of glider too.
what until mass? I cannot understand the second word. Mass
Initial,
of the glider, I
doctor.
can understand. Huh?
Initial, doctor.
Initial.
He said initial mass. Oh, he mean.
Okay. You can understand here.
Yes, doctor.
Now you'll understand. Now this is data. The M1 I measured by using the balance as 206.5 gram. This is the data. You have to copy this data on your paper, right? And M2 is 207.5. Sometime back I told you, M1, M2 sometimes equal, sometimes not equal. That depends on the glider 1 and the glider 2. In this case, M1 is not equal to M2. Is it clear? So you got the answer for your question?
It's clear for me.
M1 and M2. Now let us come to this delta. Delta starts from 10 until 100. First you add 10. 10 means 5 gram one side, 5 gram on the other side. Now total load is 10 gram. Now what is delta M2 plus delta? M2 is 207.5 plus 10 is equal to 17.5. Is it clear to you, Shabab?
Yeah, doctor. But in our papers, we don't have 10 and 30, 50.
Yes, it is different.
Okay.
Okay. Now come to this. U is measured as 43.6 and V is measured as 21.6, 21.4. The colored column, you have to copy the data on your paper. The colored column, you have to copy the data. The white column, I will tell you how to calculate. It's clear, Shiba?
Clear. Doctor,
Yes,
I have a question. But should I
Yes.
change the data and the color I have? I have 20, 40. Should I change it to 10, 20, 30, 40?
20, 40? No. I upload the same one. I think you have taken from the different one.
I download from the Blackboard before the class
yes,
starts.
Blackboard.
doctor. We have
Pardon?
20, 40, 60, 70, 80, 90
Yeah.
only. Not 10.
Without
No.
100.
No. I think you have taken from the different one.
No, doctor, go back to the Blackboard and see.
Yeah, it's in
doctor,
the
in
home
Blackboard.
page.
Yes, doctor.
Wait. I will check it. The experiment number 2, right? Experiment
Yes,
number 2.
it's on the home page.
Yes, yes, I'm checking. How come I uploaded the same file? It's taking time to read. Okay. Oh, how is it changed for your section? Okay, you copy this data from that. Why? I don't know how it is changed for your section. I upload the same file. Okay, no problem.
If you
Well,
can upload
We ch-
again,
we should
doctor.
change it, or I'm sorry. Should
you
we
copy
change it?
you copy the
cop-
data required 20, 40, something.
Okay, so okay, clear.
You copy the data which is written on your paper. Clear?
Okay.
Yeah.
So you use 2040.
Whatever the data is given for you is 20, 40, 60, 70, 80, 90. Is it clear? You pick
Clear.
the value of U and V for 20 gram, and 40 gram, 60 gram, 70 gram, 80 gram, 90 gram. Clear?
Crystal.
Yes, clear.
Yes, you copy only this 20, right? 40, 20, 40, then 20, 40, 60, 70, 80. Okay. 20, 40, 60, 70, 80, 90. You take this with this value. Okay. Then the PI. PI is equal to M1 into U. What is M1? M1 is 206.5 and U is 43.6. Multiply these two. You did not write the number written in red. The number written in red is only for your understanding.
Only the
You have to
final
write
answer.
the final answer only. The final answer is 9003.4. And PF. PF is equal to M1 plus M2 plus delta into V. M1 is 206.5, 207.5 is M2, and delta is 10 for this column into V. V is 21.4. And this is your final answer PF. Your error is PI minus PF, 9003.4 minus 9073.6 divided by PI plus PF, 9003.4 plus 9073.6 into 100. How much error I'm getting here? 0.39%. That means yes, error is less than 1%. Clear? Any doubt in the calculation, Shabab?
Yes, clear.
Okay. And similarly, you have to repeat this calculation for every column, right? For every column, you have to repeat this. Here I did it for 100. I think 100 is not included for your, I don't know how your file changed. Okay, let us not worry about that. Then at the end, you have to calculate the average, right? The average, how to calculate the average, add all the values divided by 6. 6 data is available in your report. Add all the data divided by 6, you will get the average percentage of error. Is it clear to you?
In our paper, we don't have average, I think, Doctor.
Introduce average. Write one more row.
We can add, I guess.
Yes, add.
Okay.
For error, doctor, only.
Add. Yes, add.
For error, doctor, only.
Yes. The average error, add another row. Now I'm giving this data for you. You can take some time to copy the column with a different color. This is 30, right?
Doctor,
Yes.
how we calculate the average, doctor, again?
Add all the number divided by 6.
By
All
6.
the number in the last column divided by 6.
The last column.
Yes. I'm giving some time. You can copy the data on your paper.
Doctor, we
Yes.
should write a graph for this experiment.
No graph for this experiment. Did I told you to draw the graph?
No.
No graph.
Okay.
Doctor, could I write it in PDF or should I print it?
It is better to print and write.
Because I could write it in my iPad. I don't know if it's okay.
I usually I will not prefer for using iPad for writing all these things
Okay.
because you have to do on your own. Your contribution should be there.
Okay, Doctor. I don't have a printer in my house, so
Yeah, you have to make the arrangement for that. Anyway, even if you come to the college, you should
Yeah.
be able to print your paper.
okay. I want. I can go and print it, but I mean,
Yes,
what's the deadline for us for submitting this report?
tomorrow 3 o'clock.
Okay, thank you. So I have the
Okay.
whole day.
Yes, yes. You have the time.
Excuse me,
Thank
doctor.
Friday or
Hassan?
Saturday?
Yeah.
Yes.
Friday.
Oh, sorry. For you, Saturday 3 o'clock.
Ah, okay.
Tomorrow is holiday, right? Saturday 3 o'clock for your section. Saturday 3 o'clock for your section.
Doctor, the average
Yes, sir.
should be less than 1 or
You just calculate the average. The average should be very lesser value.
lesser value.
Yes.
Doctor, U is the
Yes.
speed in gate 1, right?
Speed you are getting from gate 1, V you are getting from gate 2.
Yeah, okay. And V is it's a same speed for the two cars or two things.
Yeah,
to,
two glider.
right?
Combined speed of two glider.
For the average, doctor, we calculate just the error of average or all of it?
Yes, just last column. Error.
Ah, okay.
Doctor, if
Yes, Shabab copied.
Yes.
Khalas? Done?
For me, it's done.
Yeah, for everyone. Shall we go to the next screen? So no answer from the other side. Okay. Now you copy the data, right? And calculate the average, the percentage of error. The next, we are going to move to the next part. Theoretically speaking, the delta P, the difference in the difference in the momentum, initial momentum, final momentum, delta P, should be equal to 0. But experimentally, it's very rare to get 0. And we are getting some non-zero error. What is the reason for non-zero error? We have to find the major and minor source of error. Major and minor source of error. And here we are making two measurements.
Doctor, we don't see anything.
Yes, I know. We are making two measurements here. And you are measuring the mass m1, m2, and also you are measuring the speed u and v. And the mass m1, m2 are measured manually by us. Therefore, the major source of error introduced in this experiment is in the measurement of mass of the glider 1 and glider 2. M1, M2 could be the major source of error. The minor source of error introduced in this experiment is in the measurement of initial speed u and final speed of v. The initial speed we are measuring for the glider 1, and the final speed v we are measuring for glider 1 and 2 together. This is about the source of error for this experiment.
Doctor, why only the masses and the major source?
Yes, we are measuring the mass ourselves.
Ourselves.
U and V is measured by the instrument. And the principle of conservation of momentum for inelastic collisions in one dimension was verified with average percentage of error. I ask you to calculate the percentage of error. You write that value here, right? Write that percentage, average percentage in this place, and that gives you the conclusion. Any doubts, Shabab?
Write the average here, Doctor.
Yes, you are calculating average in the schedule. You present that here.
Okay, clear, Doctor.
Okay.
Excuse me, Doctor, for interrupting.
Yes.
Now I copy the data I need, but
Yes.
I need to print the paper.
Print the paper and write the data on the paper.
Okay, it's fine for me to go now and to the shop to.
Yes, if you have no questions, you can. The remaining time is for writing the report.
Okay.
Doctor, the last thing, we need to write the average, right?
Yes.
Here, in the conclusion. Okay. And another question is, if the class become on campus, should we do all experiment on campus, or we will continue
We will
from
inform you later. We will inform you once we got the information. Okay?
Okay.
We will inform you once we get the official information. Official announcement.
Now I take all data. Can I leave, Doctor?
Yes, if you have no questions, the remaining time is for writing the report.
Yeah, okay. Thank you, Doctor.
Okay.
Doctor.
Yes.
Excuse me. If I want calculate the average, I am calculate all the error and divide by 6.
Yes.
Okay.
Add
thank
all the numbers and divide by 6.
you. All the number of the error.
Last column.
Yes. Okay. Thank you, Doctor.
Yes. Okay.